Hi and welcome to Geeks for Geeks. Today we would be discussing the problem equilibrium index. This is a very important problem and this is very intuitive in its own ways. So let's see what the problem is. The problem is that we need to find an index where the sum of the left and the sum of the right are equal, and this index that we are considering won't be contributing to either of the sum. You need to ignore that. Let's see. So it is told that the index 2 is the index that we are considering. So let's see the left and right. So the right sum is 3 and the left sum is 3. So yes, indeed, the 2 is the equilibrium index. Now let us see if there is an equilibrium point for the second array or not. So the second element can't act because 2 and 1. This element can't act because 3 is that side and 0 that side. And this element we can't work because 3 that side and 0 that's this side. This is how the equilibrium index doesn't really exist in the array given. So the very basic brute force approach is do what is said. What I can do is I can stand on each I. Then I would go from 0, 0 to less than I, and then I would go from I plus 1 till the value of n minus 1. For each I would consider this as the left sum, consider this as the right sum. If left sum is equals to right sum, we would report that. And this I would start from 0 till the value of n minus 1. Why? Because we need to report the very first time we see an equilibrium index. So for finding out to test out each equilibrium index, you are doing big O of n operation, that is sum of all the variables except that element. Either that would be done by this side or either it would be done by this side. So now you are using only two variables to calculate the left sum and right sum again and again. So I can say that for n indices you would be doing big O of n square. This is what? This is the time complexity. Let's talk about the space complexity. You can only use variables to save the result. So I can say that is big O of 1 because variables don't account to space complexity. So now we are done. Even if we are not able to find till the end, we can just report minus 1. This is good enough. Now let us make some more observation. So we are given an array where the elements don't change, and then we are told to find, like if you observe, what is the problem in the brute force approach, that we are finding the sum all over again and again. So you need a optimized version of doing the sum of a range. So if the elements are not changing and you need a optimized version to have the sum of a range, the very first thing that should click in your mind is something known as prefix sum. If you don't know prefix sum, consider learning the prefix sum basics and then coming back to this video. So now I can simply use this prefix sum and find the values. How I can do it? The values are minus 7, 1, 5, 2, minus 4, 3 and 0. So what you can do is, the very first simple approach is, you can not only calculate prefix sum but as well as suffix sum. Okay, basically the sum from this side would be prefix sum and the sum from that side would be suffix sum. And if you only know the prefix sum basics, you can simply move forward with prefix sum. You can find the other side by using the same one. Don't worry. But still I would teach both the ideas. So prefix sum, what we can do is minus 7 plus 1 would be how much? Minus 7 plus 1 would be minus 6. Minus 6 plus 5 would be minus 1. Minus 1 plus 2 would be 1. 1 minus 4 is equals to minus 3. Minus 3 plus 3 is equals to 0. And 0 plus 0 is equals to 0. Let's calculate the suffix sum. The first value is always copied and the next value is 0 plus 3, that is 3, and 3 plus minus 4 is how much? Minus 1. Minus 1 plus 2 is how much? 1. 1 plus 5 is how much? That is 6. 6 plus 1 is how much? That is 7. 7 minus 7 is equals to 0. Now, let us use the prefix sum and suffix sum and see if the fourth index. Here you have something known as one indexing in this example. So I can simply just point out to see if this value is an equilibrium index or not. So sum before till this point would be, this is the index, this is the index. I'm just giving an idea over both of them. This is the index. So sum before that point till that point is how much? Minus 1. And if I come from that side, the sum till this point was how much? Minus 1. So yes, indeed, minus 1 and minus 1 is true. So yes, we can use the prefix sum and suffix sum to find the result. And what you can again do is, even if you don't know how to do suffix sum, you do. So this is what this is. So this is the idea where the space complexity is big O of n and the time complexity is also big O of n. That is once to make prefix sum and suffix sum and then once to calculate. So basically you are doing 3n operation. One to calculate the prefix sum, one to calculate the suffix sum, and the auxiliary space is how much? You are using 2 multiplied by n, that is you are using prefix sum and suffix sum. So can we optimize this more? And yes, we can optimize this more. How? We don't really need the suffix sum to get the sum from the range. So this is just like if I am standing at the index, if I am standing at the index 0, 1, 2, 3, if I am standing at the index 3, and this is how much? 0, 1, 2, 3, 4, 5 and 6. So this just means that I need the sum from 0 to how much? 3 minus 1, that is 2. For which side? For the left sum, and that is the current index I am considering plus 1, that is 4, till the value of n minus 1. How much? 6. And this would be contributing to the right sum of it. See, can we find 0 to 2? Yes, we can find 0 to 2 just by going to this index. Okay, 0 to 2 is solved. I can find minus 1 over here. Can we find the right sum also? Yes, indeed we can find it. How we can find it? We can take the whole sum minus 0 to 3's sum. That is, it is just like the idea. First we would take the sum of the array and then we would be removing this part. So the leftover part would be this part. So sum of the array is how much? Sum of the array is 0. And 0 to 3 sum is how much? It would be kept over 0. It would be kept at this side, that is 2. So what is kept here? 1. So 0 minus 1 is equals to minus 1. So yes, indeed, you can just use the prefix sum and find the left and the right sum of it. So now, is the complexity decreased in terms of big O? It has not decreased. But now this is not 2 multiplied by n, this is simply n, and here you need to just have build one prefix sum, not the suffix sum. So this would become 2n, that is 1 to build out the prefix sum, 1 to consider it. So yes, the complexity has decreased. Can we decrease this further? Let us see if we can decrease this further or not. So we know that the total sum we have is how much? 0. So can we do something like this, that this total sum is this one. So we can consider this as the right sum and this side would be there as the left sum. Let us see how we can do that. So see what we can do. Let us consider the very first number. So if we want to consider this number, then the very first thing we should do is, this RS contains the whole value. The very first thing is we should remove this from this whole segment. So 0 minus minus 7 is equals to plus 7. The value would become 7. So now we can say that this part is nothing but the sum of this part and this part. Can we consider that? Yes, we can consider now. So is the left sum equals to right sum? No, it is not. So let's move forward then. Now the next thing we should do is, we should add up this element into that side. Add up that element. So 0 plus plus minus 7 is equals to minus 7. Now we can say that the sum of this side is this and this side is this. Now let me remove these all to avoid confusion. Now, if we have the sum of this side, then we should remove, if we want to consider this element, we should remove that side. And this side is already good enough. Left sum is indeed minus 7. Very first thing is we should remove this one. So 7 minus 1 is equals to 6. And yes, seems fine. The sum of this side is indeed 6 and the sum of this side is indeed minus 7. Is 6 equals to minus 7? No, not. Next time what we should do is, we should include this in the left sum. Let us include that to the left sum. So left sum plus 1 is how much? Is equals to minus 6. So now we can say that the left sum is this and the right sum is this. So again, if we want to consider this element, then we need to remove this 5 from here. So 6 minus 5 is equals to 5. 6 minus 5 is equals to 1. Let us see if it is equal to 1 or not. Yes, indeed, 3 plus 5, 3 plus 2, 5, 5 minus 4 is equals to 1. So at this point, we can say that this side is what? The left sum. And this side is how much? 7 minus 7 minus 1 is equals to 6. So 1 is not equal to minus 6. So good enough. We are good to go. So now up till this point, we have what? We have the sum till this point. We have the sum till this point. And now we should include this 5 because earlier we had this. So minus 6 plus 5 is how much? Minus 1. So now what we have is, this side is left sum and this side is total sum. Next, to consider this index, what we should do? We should remove 2 from here, that is 1 minus 2 is equals to minus 1, and then it is good enough. Now we would say that yes, indeed, this side contains the sum of this side and this side contains the sum of this side. So now we can see that minus 1 equals to minus 1. So indeed, when we consider 3, we would have this. So now, just by keeping a track of two variables, we can consider this in big O of n, and the space complexity would be constant. So I'm just giving you a hint when you should use this. When you know that the past values in prefix sum can be ignored, then you use something like, I would keep a variable that sum up till this point. And this idea is also known as running sum. So this is how you can optimize this to the space complexity 1 and the time complexity as big O of n. Let's talk about the solution overview also. So we are having the length and we can calculate the whole sum in the total sum itself by using the Python's inbuilt one, and the left sum would be 0. The very first thing what we should do is, we should first remove that particular value from that thing, from the right hand side, and then the left hand side is okay enough. Then we should do it. So see, right sum is done. Now the element that was left by the right sum needs to be received by the left sum. So that is why we receive it. At any point, if this becomes true, we would return that. If the control of the program is returning here and we are not having an early return, we would say that the answer is -1. That means we didn't found any result, then only we are coming till this point. So that is why the space complexity is constant and the time complexity is big O of n. Now let us see if this approach really works or not. So let us just compile and run and see for the sample test cases. And yes, this works for the sample test cases perfectly. Let us submit this and see if we can get an AC or not. And yes, we got an AC. That was it from my side. Thank you and have a nice day.